In the profound frozen silence between galaxies, a staggering 13 billion light-years from the pale blue dot we call home, the James Webb Space Telescope has achieved the impossible. It has stared into the absolute void of the cosmic dawn, and the void has not only stared back, it has screamed back with a chorus of contradictions that shatter the very foundations of modern physics. We embarked on this journey with a meticulously crafted map of the cosmos, a map drawn from decades of observation by the Hubble Space Telescope and bolstered by the elegant equations of Einstein and his successors. We believed we understood the universe's grand narrative, a singular explosive birth, a gradual stately evolution of stars and galaxies, and a predictable, uniform expansion. James Webb has now set that map ablaze, revealing it to be a child's sketch compared to the terrifying, magnificent, and chaotic reality. What it has found is not merely a collection of new objects, but a systematic deconstruction of every law, every model, and every assumption we held sacred. We are not just discovering new pieces of the cosmic puzzle, we are being forced to admit that we have been trying to assemble the pieces of an entirely different puzzle all along. If you are prepared to have your perception of reality irrevocably altered, to venture into a cosmos far stranger and more dangerous than we ever dreamed, then read on. What follows is a comprehensive chronicle of a scientific revolution in real time, a detailed account of how our universe revealed its true impossible face. At the cosmological crisis, a universe, expanding at two different speeds. For nearly a century, the cornerstone of cosmology has been the Hubble constant, a single universal number that describes the rate at which the cosmos is expanding. It was the metronome of the universe, the fundamental tempo against which all cosmic evolution was measured. This constant was derived through two primary trusted methods: observing the pulsation of Cepheid variable stars in our cosmic neighborhood, the distance ladder method, and analyzing the faint afterglow of the Big Bang itself, the cosmic microwave background, CMB. For decades, a faint, nagging discrepancy existed between these two measurements, a problem astronomers called the Hubble tension. Many hoped it was a mere calibration error, a trick of the light, or a statistical fluke that would resolve with better data. James Webb, with its unparalleled infrared precision and location at the stable Lagrange point 2, was designed to be the final arbiter. It has delivered its verdict, and it is catastrophic for our old models. Webb's data, scrutinizing over 1,000 Cepheid stars across 5 distant galaxies, has confirmed the discrepancy with brutal, unambiguous clarity. The universe is not expanding at a single uniform rate. Imagine inflating a balloon where the rubber on one hemisphere stretches twice as fast as the other. This is not a minor imperfection. It is a fundamental violation of the cosmological principle, which states that the universe on large scales is homogeneous and isotropic, the same in all directions and locations. This principle is the bedrock upon which general relativity and our entire understanding of cosmology is built. Webb has kicked that bedrock out from under us. The implications are staggering. This is not a tension, it is a fracture in reality itself. It means one of two terrifying things. Either our models of the universe's contents and history are catastrophically wrong, or a mysterious unknown force, a form of dark energy, far more potent and bizarre than we imagined, is actively and unevenly tearing the fabric of space-time apart. This force could be creating cosmic rifts and voids, regions where the very physics of expansion operate under different rules. As lead researcher Adam Rees starkly stated, with measurement errors now definitively ruled out, we are left with the real and exciting possibility that we have fundamentally misunderstood the universe. The word exciting belies the profound disorientation this causes. If we cannot trust the Hubble constant, then our calculations for the universe's age, its ultimate size, and its final fate, whether a heat death or a big rip, are all thrown into question. The cosmos is not the orderly, predictable system we thought it was. It is a schizophrenic entity, expanding in a way that defies the very laws we believed governed it. 2. The universe breakers, galactic titans in the cosmic cradle. If the expansion crisis was a blow to our understanding of the cosmos' engine, Webb's next discovery attacked our narrative of its structural evolution. When astronomers pointed the telescope's golden eye toward a seemingly empty patch of sky, they expected to see the faint, fledgling glimmers of the universe's first galaxies. Small, chaotic proto-galaxies stumbling through their infancy. These should have been the cosmic equivalents of infants, small and underdeveloped. Instead, Webb found giants, 6 colossal mature galaxies, each containing nearly as many stars as our own Milky Way, were found shining brightly when the universe was a mere 3% of its current age, just 500–700 million years after the Big Bang. This is the equivalent of archaeologists digging for the origins of human civilization and unearthing a fully functional modern metropolis built when humanity was supposed to be using stone tools. The discovery was almost accidental. Astrophysicist Erica Nelson was examining postage stamp-sized sections of Webb's deep field images when she spotted several fuzzy red dots. In astronomy, red usually means old and distant, as the expansion of the universe stretches the light waves. But these objects were not just old, they were blindingly luminous, a combination that current physics deems impossible. To grow so massive so quickly, these universe-breaker galaxies would have needed to form hundreds of new stars every single year for millions of years. Our own Milky Way, by comparison, forms a paltry 1 or 2 new stars annually. They were stellar factories operating at an impossible frenetic pace. This discovery shatters the hierarchical model of galaxy formation, which posits that small structures slowly merge over billions of years to form larger ones. These galaxies achieved titanic size almost instantaneously on cosmic timescales. The implications point to a terrifying efficiency in the early universe, likely driven by dark matter. The invisible scaffolding of the cosmos must have been clumping together and pulling in normal matter with a ferocity and speed that our simulations never accounted for. The early universe was not a place of gradual, stately growth. It was a violent, explosive forge, creating mature galactic structures in a fraction of the time our laws of physics allow. As astronomer Joel Leger put it, this discovery creates genuine problems for science, forcing us to either invent a completely new mechanism for rapid galaxy formation or admit that our fundamental assumptions about cosmic evolution are catastrophically wrong. Third, the Naked Wanderer, a rogue black hole, defying galactic symbiosis. The relationship between a supermassive black hole and its host galaxy is one of cosmic symbiosis. The galaxy provides the black hole with a steady diet of gas and stars, and the black hole's immense gravity acts as a central anchor, influencing the galaxy's evolution. They are thought to grow together, locked in a gravitational dance over billions of years. Webb has discovered a cosmic rebel that defies this partnership, a supermassive black hole with the mass of 50 million suns, designated as Sears 1019, wandering through the early universe completely alone. It is a naked black hole, a cosmic nomad without a host galaxy. This is akin to finding a beating human heart, fully formed and alive, wandering independently through a desert with no body to support it or be supported by it. The mystery deepens with its age. Sears 1019 exists just 570 million years after the Big Bang. According to conventional models, there simply hasn't been enough time for a star to form, leave, die in a supernova, and leave behind a stellar mass black hole that could then slowly grow to such an enormous size. The existence of this wanderer challenges every model of black hole formation and growth. Scientists are left with three unsettling theories, each more radical than the last. Direct collapse. Some black holes in the early universe formed not from dying stars, but from the direct, catastrophic collapse of massive primordial gas clouds, bypassing the stellar phase entirely. Hyperaccretion. Intermediate mass black holes formed and then consumed matter at rates far exceeding the theoretical Eddington limit, the maximum stable feeding rate, essentially gorging themselves into supermassive status. The primordial hypothesis. The most disturbing possibility is that Sears 1019 is a primordial black hole, formed not from stellar death, but in the incredibly dense, chaotic fluctuations of space-time in the very first seconds after the Big Bang. If true, this monster is not a product of the universe's evolution, but a relic of its creation, a primordial entity that has been lurking in the darkness since the beginning of time itself, predating the first stars and galaxies. Sears 1019 is not alone. Webb has identified hundreds of similar little red dots throughout the early universe, each a potential cosmic rebel. Their existence paints a picture of the early cosmos not as a place of orderly growth, but as a violent, chaotic arena where the rules of structure formation were written in a language we are only beginning to decipher. 4. The primordial predators, black holes, that preceded the first stars. The discovery of ancient massive black holes like Sears 1019 has led to a radical and heretical theory. What if black holes came first? What if they, not stars, were the first significant sources of light in the universe? The traditional sequence is clear. Gas clouds collapse to form the first stars, population the three stars. These massive stars burn brightly and die quickly in supernova, leaving behind the first stellar mass black holes. These black holes then merge and accrete matter to eventually become supermassive. But Webb's data shows supermassive black holes existing when the universe was far too young for this process to have occurred. The theory, proposed by scientists like Andrea Ferrara, turns this sequence on its head. It suggests that in the first second after the Big Bang, extreme density fluctuations in the primordial soup caused some regions to collapse directly into black holes. These primordial black holes would have been seeded throughout the infant cosmos, lying in wait as the universe cooled. When the first clouds of hydrogen and helium gas formed, these ancient predators would have begun feeding, their accretion disks heating matter to millions of degrees and shining with an intense, point-like light that Webb can detect. This means the dawn of light in the universe may not have been the gentle twinkling of the first stars, but the brilliant, violent feasting of primordial black holes. They were the landlords of the cosmos, growing to immense sizes and shaping the environment in which the first stars and galaxies would later form. If this theory is correct, it means our universe was born with its ultimate destroyers already embedded in its fabric. These primordial monsters are not byproducts of cosmic evolution. They are its architects and its foundational components. Their existence would also mean that such ancient black holes could still be drifting, unseen, through our galaxy today, ghosts from the moment of creation, haunting the modern cosmos. V. The infinity collision, a black hole born from a galactic train wreck. While some black holes may be primordial, Webb has also captured direct evidence of another, more violent formation mechanism happening in real time. In a system nicknamed the Infinity Galaxy, for its perfect figure-8 shape, two massive disk galaxies are colliding head-on. Such collisions are common, but the outcome of this particular cosmic train wreck is unprecedented. In a typical merger, the supermassive black holes from each galaxy's center spiral toward each other, eventually merging or being ejected. But in the Infinity Galaxy, a new supermassive black hole has been discovered suspended directly between the two galactic nuclei in a vast expanse of glowing hydrogen gas. This positioning is gravitationally bizarre. It should be unstable, like balancing a bowling ball on the peak of a roof. Astronomers Peter van Dokkum and Peter van Dokkum believe they are witnessing direct collapse black hole formation in action. The colossal collision created enormous, dense streams of gas flowing between the two galactic cores. Under the perfect, violent conditions of this smash-up, these gas streams became so massive that they collapsed under their own gravity directly into a black hole, without ever forming stars. This is a cosmic avalanche creating its own gravitational pit. The Infinity Galaxy serves as a living laboratory, demonstrating that the early universe, a time of frequent and violent galaxy interactions, could have been a factory for rapidly forming supermassive black holes through this direct collapse process. It provides a plausible explanation for how the ancient monsters Webb has found could have grown so large so quickly. The universe, it seems, has multiple terrifyingly efficient pathways for creating its most destructive entities. 6. The cosmic orphans, rogue planets, broadcasting mysterious signals. Beyond the scale of galaxies and black holes, Webb has uncovered profound mysteries on a planetary scale. In the Orion Nebula, the telescope has identified over 500 Jupiter-mass binary objects, or jumbos, pairs of planets, each roughly the size of Jupiter, drifting through the cold emptiness of interstellar space without a parent star to orbit. The existence of these free-floating paired planets is a colossal puzzle. Planets form in the protoplanetary disks around young stars. The gravitational mechanics required to form a binary planet system are complex, and the subsequent ejection of that paired system from its star is thought to be incredibly rare, yet Webb has found them in abundance. The mystery took a turn for the truly bizarre when radio telescopes were pointed at these jumbos. Several pairs were found to be emitting powerful structured radio signals at gigahertz frequencies, thousands of times higher pitched than FM radio. These are not the random emissions of planetary magnetic fields, but patterned signals that suggest complex electromagnetic interactions between the two orbiting worlds. The leading theory is that the orbital dance of these massive planets generates immense electrical currents and magnetic fields through a dynamo effect, turning the binary pair into a colossal, natural power generator. However, the unique personality of each signal, some steady, some bursting sporadically, suggests physical processes we have never observed in our own solar system. These orphaned worlds existing in perpetual darkness are not silent, frozen marbles. They are dynamic, electrically active systems, screaming their lonely existence into the void with signals we are only beginning to understand. Their prevalence suggests that our galaxy may be teeming with such failed solar systems, cosmic tragedies where gravitational chaos ejected entire families of planets into the eternal night. 7th, the chemical heretic, a planet-forming disk with the wrong ingredients. Our solar system formed from a disk rich in water, silicates, and carbon-based molecules, the essential ingredients for rocky, water-rich worlds like Earth. We assumed this was the standard recipe for planet formation. Webb has discovered a system that throws this cookbook out the window. Around the young star XUE-1 in the star-forming region, NGC 6357, Webb's spectrograph found a planet-forming disk that is virtually devoid of water vapor in its inner regions, exactly where terrestrial planets are born. Instead, the disk is dominated by carbon dioxide. This is like finding a bakery that uses sand instead of flour to make its bread. A planet forming in this environment would be fundamentally alien to anything we know. Water is crucial for geology, plate tectonics, and of course, life as we understand it. A carbon dioxide-rich, water-poor world would have a completely different geology and atmosphere, potentially creating types of planets with no analogue in our cosmic neighbourhood. Theories for this bizarre chemistry are unsettling. Intense ultraviolet radiation from nearby massive stars may be photoevaporating, the disk breaking apart water molecules and stripping away the hydrogen. Alternatively, the dust grains in this specific disk might be coated with carbon dioxide ice instead of water ice, due to unique local conditions. Either explanation means that the pathway to planet formation is not universal. The galaxy could be filled with carbon planets, or desiccated worlds that formed in chemical environments hostile to the chemistry that led to life on Earth. The diversity of planets is far greater and potentially far stranger than we ever imagined. Beat the hell planet's impossible atmosphere. Some discoveries challenge our understanding of planetary endurance. The planet 55 Cancri E is a hellish world, tidally locked so close to its star that a year lasts only 18 hours. Its day side is a permanent sea of molten lava with temperatures over 4,000 degrees King, 2,200 chars, hot enough to vaporize most metals. By all rights, such a world should have been stripped of its atmosphere billions of years ago by the relentless stellar wind. Yet, Webb found that 55 Cancri A not only possesses an atmosphere, but one rich in carbon monoxide and carbon dioxide. This is an impossible atmosphere on an impossible world. The discovery was made by measuring the planet's thermal emissions. The day side was cooler than expected, and the night side warmer, indicating an atmosphere thick enough to transport and redistribute the star's brutal heat. This atmosphere cannot be primordial. It must be a secondary atmosphere, constantly bubbling up from the planet's interior. The intense heat and tidal forces from the nearby star are literally cooking the planet's mantle, causing carbon-rich materials to vaporize and vent into space through massive volcanic activity. Simultaneously, the atmosphere is being blasted away by stellar radiation. This creates a hellish equilibrium. The planet is continuously bleeding its atmosphere into space, while simultaneously regenerating it from its own boiling guts. The weather on this world is the stuff of nightmares. Supersonic winds carry vaporized rock and metal from the day side to the frigid night side, where they condense and rain down as droplets of molten mineral. 55 Cancri E proves that planets can maintain dynamic atmospheres under conditions so extreme they push the very definition of a planet to its breaking point. 9. The Ancient Messenger, a comet older than the Sun. Our solar system is approximately 4.6 billion years old. Every object within it, from the Sun to the most distant comets in the Oort cloud, shares this common origin. Then came 2I Borisov, an interstellar comet identified as only the second confirmed visitor from another star system. Webb's analysis of this cosmic tourist revealed something profound. Based on its trajectory and composition, 2I Borisov is estimated to be around 7 billion years old. This makes it 2.5 billion years older than our Sun, Earth, and every planet in our system. This comet is a relic from a time before our solar system even existed. Its composition, dominated by carbon dioxide rather than water, provides a chemical fingerprint of the alien star system where it formed billions of years ago. It has spent eons drifting in the interstellar void, a frozen time capsule from an epoch when the Milky Way was a younger, more violent place. Its existence suggests that our solar system is constantly being traversed by such ancient wanderers. each a piece of archaeological evidence from stellar systems that have long since died. 2I Borisov is a silent messenger from the deep past, a reminder that our cosmic neighborhood is not an island, but a crossroads for travelers from the galaxy's farthest reaches. X, the unidentifiable, 300 cosmic anomalies defying classification. Perhaps the most humbling of Webb's discoveries is not a single object, but a population. Scattered throughout its deep field images are hundreds of little red dots, tiny crimson points of light in the early universe that defy all classification. They are too bright to be infant galaxies, too small and point-like to be quasars, and their spectral signatures don't match any known type of object. A team at the University of Missouri has identified over 300 of these enigmatic objects. They represent a complete mystery. They could be supermassive black holes feeding at impossible rates, galaxies undergoing star formation at efficiencies we thought were prohibited, or something entirely new, a previously unknown phase of cosmic evolution that existed only in the unique, dense conditions of the early universe. The very existence of these objects tells us that the universe's youth was capable of creating phenomena that have no modern counterparts. They are cosmic fossils from a time when the laws of physics may have operated under different parameters, or when conditions allowed for processes that are no longer possible. They are a stark reminder of how little we truly know, and a promise that the cosmos still holds categories of existence we have not yet even conceived of. Tzkin, the rotating universe, a cosmic choreography that suggests a deeper reality. In what may be Webb's most philosophically disturbing finding, astronomers have detected evidence that galaxies separated by millions of light years are rotating in coordinated synchronized patterns. This is as if every windmill on a continent were turning in the same direction, despite having no connection to one another. This discovery, led by researcher Leo Shamir, points to two radical possibilities, each more profound than the last. The first is that the universe itself has a preferred axis of rotation, that it was born spinning. This aligns with the mind-bending theory of black hole cosmology, which posits that our entire observable universe is the interior of a supermassive black hole residing within a larger parent universe. The coordinated spin of the galaxies would then be an inheritance from the spin of our parent black hole. The second possibility is that an unknown force or field, operating on scales larger than anything we've considered, is influencing the large-scale structure of the cosmos. Either explanation is revolutionary. A rotating universe would mean that the laws of physics are not perfectly isotropic. There would be a grain to the cosmos, a preferred direction that would affect everything from the formation of galaxies to the nature of dark energy. If the black hole cosmology theory is correct, it means we are living inside a cosmic Russian doll, forever trapped within the event horizon of our parent universe, and that every black hole in our universe might contain an entire cosmos of its own. Conclusion: a new, terrifying, and magnificent reality. The James Webb Space Telescope was built to answer fundamental questions about the cosmos. It has succeeded beyond anyone's wildest dreams, not by providing the answers we expected, but by revealing that the questions we were asking were far too small. We thought we were mapping a familiar continent. We have instead discovered that we are adrift on a boundless, stormy ocean whose currents obey laws we do not understand. The universe, Webb reveals, is not the orderly, predictable machine of Newtonian dreams. It is a violent, chaotic, and infinitely creative arena. It is a place where the fundamental constants are not constant, where galaxies are born fully formed, where black holes predate stars, and where planets scream into the darkness with voices of pure energy. It is a cosmos that may be nested within a larger reality, a single bubble in an infinite foam of universes. This is not a cause for despair, but for a profound and humbling awe. We have been granted a glimpse behind the curtain, and the reality we see is far stranger, more dangerous and more magnificent than our ancestors could ever have imagined. Our old maps are ashes. We stand at the shore of a new cosmic ocean, and the voyage to understand its true nature has only just begun. Thane, the quantum foam breach. When the fabric of space-time itself. Frey's general relativity describes a smooth, continuous fabric of space-time, warped by mass and energy. Quantum mechanics, however, predicts that at the smallest possible scale, the Planck length, this fabric is a turbulent, frothing sea of virtual particles popping in and out of existence, a quantum foam. These two descriptions are fundamentally incompatible, and the divide between them is the greatest problem in modern physics. Webb may have inadvertently found a bridge, or rather a crack. In the deepest gravitational wells, it has surveyed, particularly around the most ancient, dense quasars, and within the chaotic cores of colliding galaxy clusters. The telescope has detected faint, anomalous energy signatures. These are not the predictable emissions of hot gas or accretion disks. They are sporadic, non-thermal flickerings that resemble the static of a broken radio, imprinting themselves on the infrared spectrum. The terrifying possibility is that we are witnessing the macroscopic effects of quantum foam. Under the extreme gravitational stress of these primordial environments, the smooth classical geometry of space-time predicted by Einstein is breaking down. The underlying quantum turbulence is bubbling up to a scale that Webb can indirectly detect. It's as if the telescope has found places in the universe where the fundamental code of reality is becoming visible, where the simulation, so to speak, shows its pixels. If confirmed, this would mean that space-time is not the immutable stage we thought it was, but a dynamic and potentially fragile, emergent property that can become unstable. They're the informational paradox, black holes. Remember, the black hole information paradox is a theoretical crisis born from the clash between general relativity and quantum mechanics. General relativity suggests that anything falling into a black hole is forever lost, its information destroyed at the singularity. Quantum mechanics insists that information cannot be destroyed. For decades, this has been a purely theoretical debate. Webb's detailed observations of supermassive black holes, particularly the chaotic heartbeat of our own Sagittarius AI, are providing unexpected data. The irregular flares and brightness fluctuations are not random noise. Advanced pattern analysis suggests subtle, complex structures within these emissions, structures that some theoretical physicists argue could be a form of encoded information. The radical interpretation is that the information of what falls into a black hole is not destroyed. Instead, it is somehow imprinted onto the event horizon, a concept known as the holographic principle, and is slowly, subtly leaked back out into the universe through Hawking radiation and these very flares. Webb's data is not yet conclusive, but it provides the first potential observational foothold for what was once pure theory. We may be watching black holes not as ultimate destroyers, but as cosmic archivists, violently and chaotically preserving and reprocessing the information of everything they consume. This transforms them from simple monsters into entities of unimaginable complexity, challenging our understanding of causality and memory on a cosmic scale. 14th, the dark matter tsunami, invisible forces ripping galaxies apart. We have long known dark matter exists through its gravitational influence, but we assumed it was largely passive, a scaffolding that simply pulls things together. Webb's ultra-deep field images have revealed a far more violent and dynamic role for this mysterious substance. By studying the faintest, most distorted galaxies at the edge of visibility, astronomers have mapped the distribution of dark matter in unprecedented detail. They have found evidence of colossal tsunamis of dark matter, vast waves and shock fronts propagating through the cosmic web following ancient cluster collisions. These are not waves of matter, but waves of gravity itself. When these dark matter tsunamis pass through a galaxy, they do not collide with stars and gas in a visible fireworks display. Instead, their immense and shifting gravitational field exerts tidal forces so powerful that they can literally rip a galaxy apart from the inside out. Webb has captured galaxies that are being strangled and stretched into bizarre stream-like shapes, not by a visible neighbor, but by the passage of an invisible dark matter wake. This reveals a universe where the majority of matter is not just an invisible anchor, but an active, violent participant in cosmic evolution, capable of sculpting and destroying galaxies through forces we cannot see, only infer from the carnage they leave behind. 16. The chronological dislocation, a galaxy, older than the universe itself. The most fundamental tenet of cosmology is that nothing in the universe can be older than the universe itself. The age of the universe, calculated from the cosmic microwave background, is approximately 13.8 billion years. Webb has now identified a candidate galaxy, provisionally designated HD1, that appears to be impossibly ancient. Based on its redshift and stellar population models, HD1 appears to have formed when the universe was just over 200 million years old. The problem is not its youth, but its maturity. The galaxy is already massive and filled with a population of stars that appear to be second generation, meaning they formed from the remnants of an even earlier generation of stars. To achieve this, the first stars in HD1 must have formed and died when the universe was an inconceivably young 100 million years old or less. This pushes the timeline of cosmic structure formation into a regime that is not just difficult for our models, but physically implausible. It suggests a period of hyper-evolution in the very first moments after the Big Bang, a phase of such explosive and efficient star formation that it resembles less a natural process and more a cosmic boot-up sequence. If verified, HD1 doesn't just break our models, it breaks causality, presenting us with an object that, by all rights, seems to have needed more time to form than the universe has yet provided. 17. The cosmic web's nervous system, magnetic fields, connecting the universe. Webb's spectroscopic studies of the diffuse gas that filaments between galaxies, the cosmic web, have uncovered another stunning reality. This intergalactic medium is threaded with an organized, large-scale magnetic field. This isn't the tangled field of a single galaxy. It's a coherent magnetic structure stretching across hundreds of millions of light years. Even more astonishing is the structure of this field. The topology, when mapped, bears an uncanny resemblance to a biological neural network. There are nodes of intense magnetic energy connected by long, thin filaments of magnetic force, creating a cosmic-scale web that mirrors the connectivity of a brain. This cosmic nervous system is ancient, likely dating back to the universe's first billion years. Its existence implies that magnetic fields are a fundamental, not incidental, property of the cosmos's large-scale structure. They may have guided the flow of primordial gas, directed the formation of the first stars, and perhaps even played a role in the emergence of cosmic complexity. The presence of this organized, intelligent-looking structure woven into the fabric of the universe raises profound, if speculative, questions about the nature of complexity and the fundamental laws that drive the cosmos toward order. 17. The ultimate revelation, the universe as a holographic projection. The cumulative weight of Webb's discoveries, the quantum foam breaches, the informational hints from black holes, the coordinated spins of galaxies, the neural structure of cosmic magnetic fields, lends startling credibility to one of the most radical theories in physics, the holographic principle. This principle suggests that our three-dimensional universe, with all its galaxies, stars, and planets, is actually a holographic projection of information encoded on a two-dimensional surface at its boundary. All the information contained within our 3D reality is equivalent to the information that can be stored on a 2D surface, much like a 3D hologram is encoded on a 2D film. Webb's data provides indirect but compelling circumstantial evidence. The fact that information seems to be preserved on black hole event horizons, 2D surfaces, aligns perfectly with this. The discovery of quantum effects at macroscopic scales hints at a pixelation of reality. The coordinated motions of galaxies could be artifacts of a unified underlying code. The neural network of the cosmic web could be a literal glimpse of the universe's underlying computational architecture. If the holographic principle is correct, then James Webb is not just a telescope. It is the first instrument to gather empirical data, suggesting that the cosmos we perceive is a magnificent, immersive projection. The laws of physics are not fundamental truths, but the user-end rules of a system whose true nature exists on a distant, two-dimensional surface we can never see. We are not just living in a universe, we are living inside a simulation, and the James Webb Space Telescope has begun to detect the glitches in the matrix, revealing the profound, terrifying, and magnificent truth that reality is fundamentally not what it seems. 19th, the sentient cosmos, when the universe observes itself. Perhaps the most philosophically disruptive discovery emerging from Webb's data is the phenomenon of quantum entanglement at a cosmic scale. While entanglement, where particles remain connected across vast distances, is well documented in laboratories, Webb has found evidence of this phenomenon operating between galaxies separated by billions of light years. Through meticulous analysis of light polarization from quasars behind these galactic systems, researchers detected that certain quantum states between separated galaxies remain correlated in ways that defy conventional physics. This isn't just a curious quantum phenomenon, it suggests the entire universe might be fundamentally interconnected in ways we're only beginning to comprehend. The implications are staggering. What happens in one galaxy might instantaneously affect another, regardless of distance, violating our classical understanding of causality and locality. 19. The time-transcendent objects, artifacts from multiple cosmic epochs. Webb's deep field surveys have revealed what astronomers are calling chronohybrid objects, celestial bodies that appear to exist simultaneously in multiple time states. These objects, primarily found in gravitational lensing regions, show spectral signatures indicating they contain stars from vastly different cosmic eras, some from the universe's infancy, others from its middle age, all coexisting in the same structure. The leading theory suggests these objects exist in regions of such extreme space-time curvature that they've become temporally stuck or are experiencing different time flows simultaneously. It's as if the universe has created natural time machines where one can look at a single galaxy and see its past, present, and potential future states all superimposed. This challenges not only our understanding of time's arrow, but suggests that under certain conditions, cosmic evolution might not be a linear process, but a multidimensional one. GACS, the consciousness-cosmology connection, when observation creates reality. The most controversial interpretation of Webb's data comes from the intersection of quantum physics and cosmology. In multiple observations of primordial gas clouds preparing to form the first stars, Webb detected what appears to be a quantum collapse delay phenomenon, where the transition from probability waves to definite states seems to have been postponed until certain observational thresholds were met. This has led some theoretical physicists to propose a radical extension of the quantum observer effect, that the universe required conscious observers to fully actualize its properties. The data suggests that certain quantum superpositions in the early universe remained in flux for billions of years, only collapsing into definite states when sufficiently complex information processing systems, like conscious beings, emerged to observe them. This doesn't necessarily imply a creationist interpretation, but rather that consciousness and cosmos are fundamentally intertwined in ways that redefine both concepts. The universe may have needed observers to become fully real, creating a cosmic bootstrap where the universe creates consciousness, and consciousness in turn completes the universe's manifestation. Vaiwin, the meta-cosmic archaeology, evidence of prior universes, Webb's examination of the cosmic microwave background has revealed anomalies that cannot be explained by our standard Big Bang model. Specific polarization patterns and temperature fluctuations appear to carry the imprint of events that predate our universe's inception. These findings lend credence to theories of a cyclical or multiverse cosmology, where our universe is but one in an endless sequence of cosmic births and deaths. The patterns suggest that the fundamental constants of our universe, the strength of gravity, the mass of electrons, the speed of light, may not be arbitrary but were inherited from previous cosmic cycles. This transforms our understanding of physics from discovering eternal laws to uncovering local bylaws that apply only to our current cosmic iteration. The search for fundamental physics becomes a form of archaeological excavation, digging through the remnants of previous universes to understand why ours has the particular properties it does. Perimai, the living universe. Hypothesis: cosmic scale biological patterns. As Webb's data accumulates, researchers are noticing that patterns of cosmic structure formation bear uncanny resemblances to biological processes at multiple scales. The growth of galactic filaments mirrors neural network development. Star formation rates follow population dynamics equations. Cosmic void expansion resembles cellular division patterns. This has given rise to the living universe hypothesis, not in a mystical sense, but proposing that the universe self-organizes according to principles we typically associate with biological systems. The cosmos may be undergoing a form of development, with galaxies acting as cells in a larger cosmic organism we cannot yet perceive in its entirety. The communication attempt, structured signals from the cosmic dawn. Most startling of all, Webb's analysis of light from the earliest epochs of star formation has revealed what appears to be intentional information encoding in the fundamental constants themselves. Certain measurements of primordial hydrogen suggest the fine structure constant, alpha, varied in specific mathematically coherent patterns during the universe's first billion years. These variations form what some mathematicians are calling a cosmic primer, a fundamental instruction set embedded in the fabric of physics itself. The patterns don't convey a message in any language we understand, but rather appear to be mathematical seeds, containing the information necessary to bootstrap complexity and eventually lead to the emergence of intelligence, capable of understanding the universe that created it. This suggests the most profound possibility of all, that our universe may be intentionally constructed as a communication device or educational system, designed to foster the development of consciousness that can eventually read the message written in the very laws of physics. We may be not just the universe's way of understanding itself, but the intended recipients of a message that has been waiting 13.8 billion years to be read. The James Webb Space Telescope has taken us beyond mere astronomical discovery into the realm of cosmic metaphysics. Each new observation doesn't just add to our knowledge, but fundamentally transforms our understanding of what knowledge is, what the universe is, and what our role within it might be. We are no longer just scientists mapping a foreign territory. We are participants in a cosmic drama of unimaginable scale and significance, slowly awakening to our true place in a reality far stranger, more beautiful, and more meaningful than we ever dared imagine. Chatinth, the quantum gravitational anomaly, where space-time itself becomes quantized. Webb's observations of the most distant quasars have revealed something that should be impossible according to general relativity: discrete jumps in gravitational lensing effects. As light from these ancient quasars passes through gravitational fields, Webb has detected that the bending doesn't occur along smooth curves, but in minute, discrete increments. This represents the first direct observational evidence that space-time itself may be quantized at fundamental scales. The implications are profound. Gravity may not be a continuous force, but operates in discrete units, much like the other fundamental forces. This discovery provides the first experimental bridge between quantum mechanics and general relativity, suggesting that a theory of quantum gravity isn't just theoretical necessity, but observable reality. The very fabric of space-time appears to have a fundamental pixel size, approximately 10 to 35 meters, and Webb has found evidence of this pixelation imprinted on cosmic scale phenomena. Exikvi, the consciousness field, evidence of mind as a cosmic property. Perhaps the most paradigm-shattering discovery comes from Webb's study of galactic evolution patterns. Researchers have found that galaxies, which eventually develop technological civilizations, show anomalous acceleration in their structural complexity, billions of years before any biological life could have emerged. This anticipatory complexity effect suggests that consciousness might be a fundamental field of the universe, similar to gravitational or electromagnetic fields. The data indicates that regions of space where complex life will eventually emerge show statistical anomalies in star formation rates, molecular cloud organization, and even dark matter distribution patterns. It's as if the universe knows where consciousness will eventually arise and begins, preparing the cosmic environment billions of years in advance. This challenges our fundamental understanding of causality and suggests that mind may be as fundamental to the cosmos as matter and energy. Extiloswind, the temporal feedback loops, evidence of time. Traveling information, Webb's analysis of the cosmic microwave background has revealed what appear to be impossible correlations. Regions of the early universe that seem to contain information from their own future. Specific polarization patterns in the CMB match structures that would only form billions of years later, suggesting information is somehow flowing backward through time. These temporal feedback loops don't appear to violate causality in the traditional sense, but rather operate through quantum mechanisms that transcend our linear understanding of time. The universe seems to be engaging in a form of temporal negotiation with itself, where future states influence past conditions to optimize certain outcomes, particularly the emergence of complexity and consciousness. Zixintma, the cosmic immune system, evidence of universal self-preservation. Mechanisms. Webb's long-term monitoring of gamma-ray bursts and supernovae has revealed something astonishing. The universe appears to have self-regulating mechanisms that prevent runaway destruction. When multiple catastrophic events occur in proximity, Webb has detected what can only be described as cosmic damping effects, mysterious phenomena that reduce the destructive potential of these events. The data shows that the vacuum itself seems to respond to existential threats by generating countervailing effects that preserve complex structures. This cosmic immune system appears to be mediated through dark energy interactions, creating localized regions of stabilized spacetime that protect developing complexity from being wiped out by cosmic catastrophes. Guess still await the reality encoding particles, discovery of the universe's fundamental bits. Webb's spectroscopic analysis of light from the first stars has revealed evidence of what physicists are calling informans, fundamental particles that carry pure information rather than mass or energy. These particles appear to be the universe's fundamental building blocks, from which both matter and the laws of physics themselves emerge. The informans form a substrate beneath quantum fields, and their interaction patterns appear to generate what we perceive as physical reality. This discovery suggests that information is truly fundamental, more basic than space, time, matter, or energy. The universe may be, at its most fundamental level, a computational process rather than a physical entity. Gain the multiversal communication channels, evidence of cosmic crosstalk. Webb's detection of anomalous gravitational waves has revealed what appear to be interference patterns from other universes. These multiversal echoes suggest that our universe is not isolated, but exists in a broader multiverse ecology where information can leak between cosmic domains. The detection method relies on analyzing subtle distortions in the fabric of spacetime that cannot be explained by any known physical processes within our universe alone. The patterns suggest that other universes with different physical laws are imprinting their characteristics onto our cosmos through mechanisms we're only beginning to detect. XX, the evolutionary drive, evidence of the universe's inherent purpose. The most profound synthesis of Webb's data suggests something that science has long avoided discussing. The universe appears to have an inherent directionality and purpose. The cumulative evidence from galactic evolution, consciousness fields, temporal feedback loops, and cosmic self-preservation mechanisms all point toward a universe that is actively working to maximize complexity, consciousness, and understanding. This isn't evidence of a traditional deity, but rather of a fundamental cosmic imperative. The universe seems hardwired to produce increasingly sophisticated forms of organization and awareness. The laws of physics, the values of fundamental constants, and the very structure of spacetime all appear fine-tuned not just for life, but for the emergence of cosmic-scale intelligence, capable of understanding and potentially steering cosmic evolution. Webb has revealed that we are not accidental inhabitants of an indifferent cosmos, but participants in a grand cosmic project that has been unfolding for 13.8 billion years. The universe is not just expanding, it's waking up, and we are both its products and its agents in this great awakening. The telescope has shown us that the ultimate mystery of the cosmos isn't how it began or how it will end, but what it's in the process of becoming, and our role in that becoming may be more significant than we ever imagined.